this lab, you will be using a phase separation technique called extraction to isolate an organic molecule, caffeine in this case, from a mixture. You can separate an organic molecule by extraction with an organic solvent. In this video, you can see that as the mixture is allowed to separate, different layers form. The cool thing that happens is that as the phases separate into organic and aqueous, the organic phase drags, or the proper term is extracts, organic molecule from the aqueous layer into its own phase. These are the materials you'll need for this lab. Weigh and record the mass of your caffeine tablet. Using the mortar and pestle, cross the caffeine tablet into a fine powder. Transfer as much of the powder as possible into a 50 milliliter beaker. In order to make a 0.1 molar solution of HCl, use 1 milliliter of 1 molar HCl and 9 milliliters of water. Remember, you always add acid to water, not water to acid. Pour the HCl solution into the 50 milliliter beaker. Do this twice. You should have a 20 milliliter solution at the end. Put the stir bar inside the beaker. Make sure you note the volume before you start boiling. Let it boil until you have 7 to 10 milliliters of the mixture left. When it's cold to the touch, remove it from the hot plate and allow any solid to settle. Remove the spin bar from the 50 milliliter beaker. Once you have allowed the solution to cool and the solid has settled to the bottom, decant just the liquid into a centrifuge tube. We really don't want any of the solid to get in. And then put it in an ice bath for 3 minutes.
Measure 2 milliliters of methylene chloride. After 3 minutes, add the methylene chloride to the test tube. Screw on the cap and invert the test tube to mix the solutions. This is when the extraction occurs as you shake the aqueous and organic mixture. This is how the organic and aqueous layers separate. When the mixture doesn't separate well, put the test tube in the centrifuge for about 30 seconds. Don't forget to balance the centrifuge using another test tube. Now you are going to extract the organic layer that contains caffeine, but how do we know which phase is organic? To figure this out, add water to the test tube. Whichever phase grows is the aqueous layer. Here you can see that the top layer is growing, therefore the bottom layer is the organic layer that we extract. Use a pipette to extract the organic layer carefully. When you extract the organic layer, press the bulb of the pipette down all the way before you insert the pipette into the test tube. Let the pipette reach to the organic layer to extract and release the bulb to draw the organic solution. Also, try to leave some organic layer at the bottom of the test tube so you don't draw a lot of the aqueous solution along with it. Repeat the extraction steps 2 more times. Now we are going to add sodium sulfate into the organic solution we just extracted to dry it, meaning remove all the water left in the organic solution. As you're swirling the beaker, you'll see the clumping part and some free or loose pieces in the solution. The free or loose pieces let you know that there's no more water left in the solution, so you can stop adding sodium sulfate once you see those pieces start to form. Tear the flask and record the mass for later calculation. Using a pipette, transfer the dried organic solution into the teared flask. To get all the product inside the beaker, wash the sodium sulfate with 2 milliliters of methylene chloride and add it to the flask. Boil off methylene chloride in the hood by heating the flask. Methylene chloride only has a 40 degrees Celsius boiling point, so if you see overboiling, reduce the heat. After removing the solvent, you should see the solid left on the bottom of the flask. This is the product. After the flask cools down to room temperature, weigh the flask with the product, calculate the percent recovery, and take an IR spectrum. Use this formula to calculate the percent recovery. The IR spectrum of caffeine should look like this. Write out the structure of caffeine and find out which peak corresponds to which functional group.